All right, guys, so we are going to go into lesson 8.4, the last lesson of chapter 8. So let me present my screen so we can get started. All right, so we do have 3 vocabulary terms. Let me jump onto the online textbook to get started with the first one. So first we have corresponding angles. We talked about corresponding parts already in almost all of the lessons of this chapter. All right, so we have corresponding angles when we talk about our parallel lines cut by the transversal. We could also talk about the corresponding congruent angles of 2 triangles, but here's the definition of corresponding angles related to your 2 lines and a transversal. So 2 angles that are formed by 2 lines and a transversal in corresponding positions. Okay, angles 2 and 6 are corresponding angles. Now, angles 2 and 6 are only congruent corresponding angles when the lines are parallel. If the lines aren't parallel, we can still talk about 2 and 6 as being corresponding based on location, but they're not congruent to each other. Okay, only if the lines are parallel. The next word is ratios. For some reason, this is not part of your glossary, so I just went to the web and found a very basic math-related ratio definition. All right, a ratio is a relationship between 2 or more values. All right, A units per B units, the notation A over B or A dot dot B, or we use the word 2, right? TO, that wasn't listed here, but you could also write it as A to B. Okay, so again, if I'm going too quickly, pause the video, finish writing your vocabulary. All right, we have one more, which is proportion. This one also wasn't in your glossary. A proportion is an equality of ratios. So when you take 2 ratios and set them equal to each other, we call that a proportion. If you take 2, 3, 4 ratios and set them equal to each other, we call that an extended proportion. Okay, so that's an example of a proportion. All right, let me get rid of all these web searches that I was looking at. Okay, so let me get back to the notes. Okay, so we have some theorems and some quick examples to go through for today's lesson. First, we have the triangle proportionality theorem, which says that if a line parallel to one side of a triangle, so we're talking about this line here, TU, is parallel to this side of the big triangle, okay, and TU intersects this side and this side of the large triangle, then what happens is TU divides this side of the triangle proportionally to that side. So you can set up proportions like the one listed below. It says that RT to TQ is equal to RU to US. Okay. You could also say that RT to RU is equal to TQ over US. Or you could also say, so this is one that works, okay? Or you could also say this entire length, we can name that QR. So I could say that QR to, let's say, QT is equal to this entire length here, SR to SU, okay? Or you could say the entire length, QR, to the top piece here, RT, is equal to the whole thing, SR, to the top piece, RU. So there's lots of different proportions that can be formed based on this theorem, okay? One thing you don't want to do is like crisscross. You wouldn't want to say that RT to U at, you don't want to crisscross. So just remember, no crisscrossing. That does not work, all right? The next theorem is just the converse of the first. So this theorem says that if the sides are divided proportionally, then you'll know that this line is parallel to that. We're going to use that in one of our examples in just a minute. Okay. So, oops, let me scroll down. So here it says, in the diagram, it says that QL FS is parallel to UT, which is marked, okay? And it says that RS is 4, ST is 6, QU is 9. What is the length of RQ? So based on the first theorem, this line is dividing the two sides of the triangle proportionally. So what do you think you could write? Think about it. Write down a proportion. There's more than one that'll work. You could say 9 over x is equal to 4 over 6. Or you could say x over 4 is equal to 9 over 6. Or you could say x over x plus 9 is equal to 4 over 10. Where did that come from? X plus 9 is the whole length, right? And 10 is the whole length. That's where I got, oh darn. Try to move those back. 10. It's not going to let me write a 10. You guys can see, you add those together and get a 10. 10 is the whole length. That's where that 10 came from. All right, so you don't need to write all these proportions. You just have to write one and solve it. I'm just going to use the first one that I wrote. All right, so cross products. You have 36 is equal to 6x. Divide both sides by 6, and you get x is equal to 6. All right, lots of different options, though. Example 2. Now we want to use the converse of the theorem we just talked about. So the converse, remember, is going to be used to show that this is parallel to that. And it's only parallel if the sides are in proportion. Okay? So you're told that BA, this is 33 centimeters. CB is 27. CD is 44. And DE is 25. We want to know, is the shelf parallel to the ground? Is DB parallel to AE? Well, it's only parallel if the sides are proportional, if they're cut proportionally. So is 27 over 33 proportional to 44 over 25? Or you could also check, is 27 over 44 proportional to 33 over 25. Okay. So if you simplify, and it doesn't matter to me which, ratios you use. I think I did, what did I do in my notes? I think I did this first one. Yeah, it looks like I did this first one. I simplified to 9 over 11, and then the other one doesn't simplify. So I can see that they are not equal. Therefore, I know that BD is not parallel to AE because the sides are not proportional. Okay. All right. Theorem 8.8, the 3 parallel lines theorem. This says that if you have 3 parallel lines that are intersecting 2 transversals, then the transversals are being divided proportionally. Okay. Pretty much same kind of thing with this. You can set up a bunch of different proportions. Don't crisscross. Okay. Do not cross. So what I mean by that is you cannot say that UW to XZ, you cannot say that that is equal to WY over VX. Don't crisscross when setting up your proportion, okay? Otherwise, there's a ton of different proportions that you can set up that will be correct, okay? So the one that they set up was a UW to VX, or sorry, I read it wrong. UW to WY is equal to VX over XZ, okay? And that's just one of the many. You could also say that UW to WY is equal to VX over XZ, or you could say that UW to VX is equal to WY over XZ. So lots of different options of how you could set them up, okay? All right, so example 3. It says in the diagram, angle 1, 2, and 3 are all congruent. Okay, so 1, 2, and 3, if they're all congruent and they're all corresponding, that means that these lines are parallel. So the theorem we just said above is true. 3 parallel lines cutting 2 transversals. The transversals are divided proportionally. All right, so you're asked to find the distance from H to F. That's what the problem is asking you to do. All right. Now this distance is 300. This distance is 150. This distance is 120. We're trying to find the distance from here to there, but we don't know this one. Options. If you want to solve for X, if you want to figure out how long it is from H to G, and then add those together to get the whole length, you could do that. Or you could say that this entire thing, I'm going to call it Y, just so I can set up a few different proportions. You could say the entire length that you're looking for is Y. All right, and this entire length over here from this point down to this one, if I add the 300 and the 150, that's 400. So you could say like 120, this part here, over Y is equal to 150 over 450, the whole thing. And you can solve for Y and get your answer. So when I cross multiply 450 times 120, that's going to give me 54,000 is equal to 150Y. Then divide by 150 and you get Y is 360. So that is the answer. But just to show you another option, let's say I solve for X. So let's say I do 120 over X is equal to 150 over 300. So now when I cross multiply 120 times 300, that's going to give you 36,000 is equal to 150x. Then divide by 150 and you get 240. So if this piece here is 240 units long and this piece here is 120, then we know the whole thing is 360, which is what we found doing it this way. All right, so you could solve for X first, then just do your addition to figure out the whole length, or you could set up a proportion to solve for Y, and that is your answer. Okay, so options. All right, I think this is the last theorem. Let me look ahead. Yeah, this is the last theorem, the last example. This is the triangle angle bisector theorem. And this says that if you have a ray, if a ray bisects an angle of a triangle. So again, you're looking first, focus on triangle ABC, and then this ray is cutting angle C in half. The ray is also dividing this segment proportional to the other two sides of the triangle. Okay, so this segment here breaks into segment AD and segment DB. And those two segments are proportional to the other two sides of the triangle, AC and BC. So you can set up a proportion that says AD, this piece here, to DB, this piece here, is equal to CA, this piece here, to CB. Okay? You could also write it as AD, so this piece here, to AC is equal to DB to CB. Again, you don't want to crisscross. You don't want to like write a proportion involving this piece over that piece is equal to this piece over that. That wouldn't make any sense. Okay, that would not work. All right, but you do have two options of how to write your proportion. So the last example, where is it? Oh, it got moved to the last page. Hold on, let me erase that. Go down here. Okay. So it says here, in the diagram, angle QPR, that one there, is congruent to angle RPS, this one here. Okay. Use the given side lengths to find the length of RS. So I'm looking for the entire length, RS. Oh, no, I'm sorry. X is what I'm looking for, right? I'm looking for R to S, this piece here. Okay. Well, if this entire length is 15, how can I represent this piece of it? what could I use? What my algebraic expression could be used to represent that part? If the whole thing is 15 and this piece is x, it'd be 15 minus x. All right. Now that I have that written, this is the angle bisector. So this side is being divided proportionally to the other two sides of the triangle. So I could write 15 minus x over 7 is equal to x over 13. Or I could write 15 minus x over x is equal to 7 over 13. Basically, one of those two would be the proportion you want to use. I did both of them in my notes, so I'll just go ahead and solve this one. You'll get the same answer either way, because if you look, you get the same cross products when you multiply across. So I have 7x is equal to 13 times the quantity 15 minus x. All right, so 15 times 13, that's going to give you 195 minus 13x when you multiply by 13. And then I'm going to add 13x to both sides. So I have 20x is equal to 195. And then I'm going to divide both sides by 20. Oh, I'm running out of room down here. And I get x is equal to 9.75. So you will have plenty of time to do practice similar to this in class over the next few days, but that is it for this lesson, guys. So that brings us to the end of chapter 8. I'll see you back here when we start chapter 9. Bye.